Hello everybody, my name is Jun Wan. This lecture, I will show you how to read mapping quality file generated by our core. There are several levels of quality control or RNAseq analysis. The first one is, you already know, is a fast QC generated by the sequencing, and which shows how the quality look like the sequence in terms from the perspective of sequencing. And second one is after we align the sequence to reference genome, there is a file show the percentage the sequence can be aligned to reference genome. Another mapping file we generated is the mapping rates to gene region. Because this is a messenger RNA sequence, we expect majority of rates should be mapped to the gene region. And here, my core used the NGS utils with COM and the BAM states try to generate this profile. The last one is after we summarize gene expression, we also need to see the relationship between samples in terms of gene expression. But we will introduce this part at the lecture later. Here is the alignment statistics file we generated after star mapping. And you can see the first row shows raw rates for each samples. Here we have 8 samples in 2 conditions. And the second row shows the mapped rates. When we map the raw rates to the reference genome, how many rates can be mapped under the cutoff. Here shows the high quality rates after we remove some low quality rates, and that's the percentage. There are several information you have to be careful. The first one is the total rates. As Dr. Yuno emphasized before, and we may need to think about the depth, sequence depth. So here you can see even the sequence depth is over 30, but after mapping, probably the sequence depth will drop a little bit. We hope like each sample at least have about 25 to 30 million can be used for the further analysis. And also this law shows the percentage of high quality rates. Even sometimes, for example, one extreme case is if you sequence one sample with 100 million, but you only get 35 million of high quality rates, that means the percentage of high quality rates is only 35%. Even the number of rates can be used is good, but the mapping rate is pretty low. Then you have to think about or go back to check the sample, whether something was wrong there, like a possible contamination or some mess up. After we know how many rates can be mapped to the reference genome, we also want to know the location of these rates. For example, here is another file we will generate. And so we can see how many rates can be mapped to the gene, and where are located is in the coding exon or reverse coding exon, or in the genic region, intron, junction, mitochondrial, or other exons not on the coding region, promoter, UTR3, UTR3 UTR, or 5 UTR. And here shows all the rates here, and in each region we defined by the software. This is a file in terms of the percentage rather than the total rates, so number of rates. So you can easily see the quality of the sequence in terms of how many rates mapping to the genes. And here we have 8 samples, exact same as we showed the previous slides. And the risk, over 90% risk can be mapped to gene. That's really good. And also there are several other further informations you can find from this file. The first one is that you may already realize that there are two laws, coding and coding reverse. So this one means the strength was whether the protocol is strength strand specific or not. If you see about the same ratio of the coding and the coding reverse or intron reverse, other exon reverse, which means you may use the protocol non-strand specific. In this case, you can absolutely see the bias on the coding reverse strand, which means the sequence was performed with the protocol strand specific. And as I mentioned several times, because this is RNAseq analysis, messenger RNA-seq analysis, we don't expect the main high rates were located in the channel. If you found that the ratio is pretty high, then you have to go back to check the sample quality. And also there is an important raw mitochondrial percentage here. And you can see in this case, all the mitochondrial percentage is pretty low, except one sample B2, a little bit higher, 4%, but in general, all the mitochondrial percentage are under 5%, which is good. If you find some higher percentage in the mitochondrial, then you have like the 10% or even much higher, 20, 30%, then you have to check the sequence quality as well. And also, this is a junction percentage. If you are going to do alternative splicing based on RNA-seq analysis, the number of junction, the risk in the junction or junction percentage is very important. It will give you more information about the splicing.